Hello, welcome back. Today we're going to be discussing about the material balance on multiple unit systems. Remember that the general balance equation states that inputs minus outputs plus the production minus the consumption is the accumulation, and the mass balance is a mass conservation principle, right? And in the steady state with no chemical reaction, inputs equals outputs. And if we have chemical reaction, then we have production and consumption. There is no accumulation term. Now, how many processes can be generated? Let's suppose that we have this system where you have one feed here and then another feed here, and both of them yield to this A that goes into the unit one. We have product P1, and then this B you can separate to P2, and then C you input that into unit 2 with an F3, and then it yields to P3. That's any given process, right? So the first thing that we need to understand is that this is the whole system, and we can divide this in unit operations. One unit operation here, which is mixture, one unit operation here, one which is this separation process, and then one unit operation here. So each unit operation has n-1 independent balances, except for this one, which I am going to talk about that in a minute, but is n-1, n being the amount of components in the process. So we can do this unit operation as a mixture point, where F1 plus F2 yields to A, and then we can do each and every material balance for each component. We can also do for unit 1, where A is going to yield to P1 plus B, and then B is going to be equal to C plus P2, and then the unit 2 is going to be C plus F3 is going to be equal to P3, right? And each one will have n-1 independent balances. The mixture point is this point where you input F1, F2, and it will yield to A. And here, the composition is going to vary. But in the separation point, V is going to be separated in P2 and C. So since this is not varying, the composition, when you separate V in two streams, then this will yield to a material balance which the composition is not going to be varying. So in that sense, it's not going to be an independent equation, the one for each term, the one for each component. So you have to be very careful with this. And in the global process, you also have n-1 independent balance, which in this case, this is the global process, right? So you have F1, F2, and this is important idea because the single unit balances add up to give the global balance. So if you add up the mixing point, the unit 1, the separation point, the unit 2, right? And you have these balances, and you add left side, and you equate that to right side, and you add this up, right? A, B, and C are going to cancel out, and it will yield to inputs F1, F2, F3, which are these ones, F1, F2, and F3 are inputs, are going to be equal to P1, P2, and P3, which are the products, right? And these A, B, and C are going to be streams that are internal streams. So here F means feed and P means product, right? But you can also do subsystems of contiguous unit operations. So you can do this subsystem of this mixture point and unit 1, where you will have, let's say, F1 plus F2 is going to yield to P1 plus B. And you can also have this unit 1 with the separation point. You can also have B or this separation point with unit 2. And you can also do these 3 or even these 3. This is not very common, but you can do that, right? And of course, the balance will yield that this is a sum of these processes, which, since this is a sum, it will mean that these are not independent balances from the original ones, okay? And you can do this degree freedom analysis. Let's suppose that you have this example where you have this input to this unit 1, and you are going to separate this into 2, 3, and 4. 4 will have a separation point, a mixture point in this case, with this feed 5, and it will yield to 6, and this 6 you will have it in a unit operation 2, which goes to separation in 8 and this string 7. So you can do this freedom degrees analysis, and you state here that unit 1, in unit 1, string 4 is 30% of the feed. So this guy is 30% of the feed, right? So this will yield to, if you do your degree freedom analysis in unit 1, where you have 3 unknowns, you don't know M3, you don't know M4, and you don't know this X. But if you know this X, you know the other complement, the other X, right? You don't know the X of E, but if you know the X of E, you can get the X of W. So that's 1, 2, 3 unknowns. You can build up 2 independent equations, which are, let's say, 100 is going to be equal to 40 plus M4 plus M3. And for component E, if you build up for component W, that's going to be dependent on the other 2. And in the relations, here you have this relation. Unit 1, string 4 is 30% of the seed. So if you do 3 minus 2 minus 1, is going to yield to 0 number of degrees of freedom, right? Which it's a very good candidate. So you can start with unit 1 in order to get this M4, this X, and this M3, right? Now, in the mixture point, you will have 4 unknowns, which is M4X, E4, and it's M6 and XE6. In this case, you have 2 equations. You don't have a relationship. You don't have anything else. So it will yield to a degree freedom, number of degrees of freedom of 2, which is not good then to start here. Then in unit 2, you will have, let's say, M6, X6, M7 and X7, so 4 unknowns, 2 equations. Once again, the overall equation and the one for component E would be independent. No relations, so this will yield to 2 degrees of freedom, and it's not a good candidate either. And then for the process, for the whole process, this complete box, you will have these unknowns. Let's say you don't know M7, you don't know M3, and you don't know XE7, so that's the 3 unknowns. You can build up 2 equations, and it's going to be 1 degree of freedom. So in this case, you will start by unit 1. With unit 1, you can get M4, XE4, M3, right? And once that you have this, then you can proceed to the whole process, and then to the mixture point or the unit 2, etc. Right? So this degree of freedom analysis is in order for you to know where to start to attack the problem, right? And remember that in this case, you can get a system of 2 equations and 2 unknowns, or 3 equations and 3 unknowns, right? So this is about multiple unit operations. I hope that this was very helpful.